So we have learned about intrinsic semiconductor, and that every time electron gets excited from valence band to conduction band, a whole electron pair gets generated, and hole and electron separately can conduct electricity. This is what we have learned. If you can recall from current electricity chapter, the mobility mu is defined to be the drift velocity upon the electric field that we apply. So drift velocity is given by mobility times the electric field. Here, let the whole mobility be given by mu h, and electron mobility given by mu e. So the total current is whole current plus electron current. And whole current is nothing but the number of holes per unit volume, NEAVD, if you can recall, okay, times the charge of electron, times the area, times the drift speed, okay, due to holes. So the drift speed of electrons due to holes, and number of electrons into the charge of electron, area of cross section, the drift speed attained by the conduction electrons. Now NH and Ne are equal in an intrinsic semiconductor because at 0 Kelvin there are no electrons in the conduction band, there are no holes in the valence band. Every time an electron goes to conduction band, a hole is generated in the valence band. So the number of holes and electrons must be equal in an intrinsic semiconductor. So I can term it as some Ni. And therefore the current I comes out to be Ni times E times Vd due to holes is nothing but mu H into the electric field plus mu E into the electric field times A. Now, the current density J is nothing but I by A, which here comes out to be Ni times mu H plus mu E times E times the electric field capital E. Now we can compare this with sigma equal to JE, that is Ohm's law. So our conductivity sigma is given by Ni into E times mobility of holes plus mobility of electrons. So the resistivity rho is 1 divided by Ni E times mu H plus mu E. So resistivity is inversely proportional to the number of intrinsic carriers. You can say that is Ni, number of holes equal to number of electrons equal to number of intrinsic carriers, you can say. And the dependence of resistivity or conductivity on mobility of the holes and electrons, okay, is as given in the on the board, okay, as I have written. Please make a note of this important formula, because once a question was asked based on this. Once a question was asked based on this formula, so students may actually note down this particular statement. Okay. So now Based on this, let us move on to our presentation again and try to understand the concept further. So, holes are carriers in the valence band and electrons are carriers in the conduction band. I hope you are okay with that. And then electron mobility is larger than hole mobility because valence band typically is at lower energy level. So electrons don't like to jump through the holes. They prefer actually pushing the conduction electrons and conducting the electricity. Okay. So hole mobility is quite small compared to the mobility of electrons. Okay. For the same electric field, the current through the holes will have lesser drift speed compared to the current through the conduction band. And both can coexist. Now, lastly, one very important thing is that the number of intrinsic carriers depends on temperature. Please have a good look at this formula. Ni equal to N naught, some reference number, which depends on the material, times exponential to the power of energy gap, which is less than 3 electron volt, and it is fixed for a particular semiconductor. Okay, as you very well know, 1.2 electron volts for silicon. Okay, now divided by 2 times the Boltzmann constant Kb times the temperature. So as the temperature increases, this whole quantity Eg divided by 2 kBt, that ratio decreases. But it is a negative exponent that is decreasing. Okay, e to the power of minus 0.1 and e to the power of minus 0.2. If you compare, e to the power of minus 0.1 is larger. It is larger. So when negative exponents are taken, the closer you are to 0, the larger is the value, as you know. Okay. And therefore, as the ratio Eg by 2 kBt decreases with temperature, the exponent increases with temperature, or the number of intrinsic carriers increase with temperature. And since the resistivity is inversely proportional to number of intrinsic carriers, as the temperature increases, resistivity decreases. So this is unlike regular resistors we have, wherein as the temperature increases, the resistivity increases. However, in semiconductors, as the temperature increases, resistivity decreases. This is a very important point students must remember. And in the next video, we will discuss about extrinsic semiconductor. Thank you.